Good morning. My name is Bhanu Veera. I am presenting seminar about probability theorem and stochastic process. Today my topic is random process. Let us see one by one what is random process. First, introduction to random process. A random process is a collection of random variables indexed by time or space. It means random process is a collection of random variables. It collects random variables like x and y indexed by time or space. It is indexed by the time or space. A random process is the collection of random variables indexed by time or space. It is used in fields like engineering, science, and finance. Random processes are used in fields like engineering, science, and finance. Random variables are used in fields like engineering, science, and finances. Examples like electronic noise and stock market fluctuations, weather changes. Now, we retake the introduction to random process. A random process is a collection of random variables indexed by time or space. It is used in fields like engineering, sciences, and finances. Examples like electronic noise, stock market, fluctuations, weather changes. It is used in to find the weather changes and determine the noise of the electronic device, and it is used in stock market like the fluctuation like graph. Let us see what is a random process. Basic concepts of random process. Sample, well, there are three types of basic process of random process. First one is sample space, and second one random variable, and third one is stochastic process. Let us see what is sample space. Sample space is set of possible outcomes like one. It is a set of possible outcomes like 1, 2, 3. It is a set of possible outcomes. Random variable assigns a numeric value to the each outcome or discrete or continuous. Random variable like x and y, it is a numerical. Assigns the numerical value to each outcome or like a discrete or continuous. It tells about the nature of the random variable. It is a discrete or continuous. And let us see stochastic process. A family of random variable represents system evolution of over time. So stochastic process means it is the family of random variables and like a group of random variables representing system evolution like over time. It is represents the group of random variables. These are the basic concepts of random process. Let us recap the basic concepts like first one, sample space. It is a set of all possible outcomes. And next one, random variables. A random variable means it assigns the numeric value to each outcome like x and y, and it tells about the nature of the random variable, like discrete or continuous. Next, stochastic process. It is a family of a random variable representing system evolution over time. Types of random process. It is three types of random process, like two types of random process. One is discrete time random process, and next one is continuous time random process. Discrete time random process means index it is discrete or not. It tells discrete time random process means the random process is in discrete time. It tells the index set is discrete or not. Set is discrete or not. Examples: daily stock prices. It means daily stock prices is up and down. It tells about the graph with stock market. Next, continuous time random process. Index is set is continuous. Example: temperature over a day. Continuous random process are used to weather conditions. It is what is the temperature of day, and the practical example for each type. Uh, types of random variable, it has two types: discrete time process random variable, continuous time random process. Index set is continuous and practical example for each time. Classification of random process. It has four classifications. First one, stationary process and non-stationary process, and ergodic and non-ergodic processes. First, stationary process means stationary statical properties remains constant over a time. It means any statical properties does not change with time. It is only constant with values. And a non-stationary process means properties change over time. It means statical properties means mean, variance, and covariance, etc. Does not change with time. It is only discrete. It is only discrete or continuous. It has two qualifications. First one is first order and stationary process, and next second order stationary process. We would have it is first you is a random process which is said to be a stationary process. The statical properties does not change with time. Non-stationary process property changes over time. Okay, ergodic process and non-ergodic relation between time average and ensemble average. It means it relation between time and discrete is average. Properties and parameters of the random process. And it is mean variance, autocorrelations, and autocovariance are the statistical properties of random process. It is in a stationary process, mean variance does not change with time. That's why it is does not change with time. That is called stationary process. Stationary process have two types. First one is first order and second order stationary process. First order stationary process means the joint property of statistical properties does not change with time. And the second order stationary process random process set to be second order stationary process. The density function does not for statistical process does not change with time. That is called second order stationary process. Mean is average value of the random process or random variables. Variance means it is the correlation of the autocorrelation. It has how values are related to over time. Autocovariance measures the linear dependent at different times. Examples of random process. First one, Poisson and Gaussian and binomial process. Let us say Poisson process. Modeling counts events. It means a random process is said to be a Poisson process. Poisson process used to tells about the how many times the event occurs in a function of time. Examples of Poisson process means examples of Poisson process counting of cars or customers in a counter. That is it is go with one by one. It occurs in a one by one process. That is the Poisson process. It has limitations. Let us see that Gaussian process. Values follow from normal distribution. And binomial process. Series of independent Bernoulli trials. Bernoulli trial means number of events occur in a event. Applications of random variables. Signal processing and communications and finance. Signal processing means noise reduction and noise detecting and noise reduction in frequency and filtering that noise. Communication, data transmissions and error correcting and error detecting and modeling. Finance, forecasting and risk estimation. Illustration and case study. Illustration case study. Example: random processes, weather forecasting or stock marketing. How random process help on model temperature and rainfall variations. Real world impact and predictive capabilities. Examples. Conclusion references. Random processes are essentially in many disciplines and helping modeling analysis and prediction of uncertain systems. References and references like a probability and Pilali and probability random variables and stochastic process. Additional resources as needed. Thank you. These are the my represent of random process. Thank you.